let's find the domain of this function. So we've got log base 4 of 1 plus x over 1 minus x. The key is we know that what's inside of here has to be positive. So the big question is, what keeps x plus 1 over x minus 1 greater than 0? This looks like a problem from last chapter now. So we know how to do this problem. We do our number line thing. We say, when is the top equal to 0? That is, when is x negative 1? We ask, when is the bottom equal to 0? When x is positive 1. And if we were to give a sketch of what's going on, I could find the intercept, the y-intercept, that is, when x is 0, y is positive 1. That's over here. I would have a vertical asymptote there, and then intercept here. So it would do something like through there and up, and then across and over. So what is our solution? Our solution is, when is this positive? It's positive when x is between negative 1 and positive 1. Notice that we can't include negative 1 in this problem because it's strictly greater than. If x is equal to negative 1, this would equal 0, and what happens to a log of 0? Well, that's where it's undefined, and we have a vertical asymptote. So our domain is from negative 1 to 1. What about log base 6 of the absolute value of x plus 3? So what do we know? We know we need to keep this positive. So the question is, when is x plus 3 greater than 0? Well, this is an absolute value function on the left, and an absolute value always gives us a positive number or 0. So what would be a problem? It would be a problem if x is equal to negative 3. That is, my sketch of what's going on looks like this. So I can use any negative numbers up to negative 3, and then positive numbers, well, any numbers from negative 3 up to positive infinity. The only number that can't be used is negative 3, because that would give me negative 3 plus 3 is 0, absolute value of 0 is 0. The log base 6 of 0 is undefined, because that's where the vertical asymptote is. One more. Log base 7 of the square root of x over x minus 1. So we need to keep what's inside of here positive. We have the square root of 7 over x minus 1 needs to stay greater than 0. Well, there's two problems here. We've got a fraction, and we have a square root. So right away, we know, because of the square root, x needs to be greater than 0. Right? But what about from the denominator? From the denominator, if x is 1, there would be a problem. So what about if x is smaller than 1? If x is smaller than 1, like between 0 and 1, that is maybe a positive 1/2, what would happen? We would end up with a negative number in the denominator of this fraction. That's no good. So really, if I'm thinking about a number line, the square root will work for 0 and over, but the bottom part will only work for greater than 1 and over. So here's a 1. So our domain is from 1 to infinity. Let's just pick a number and make sure it works out. What if we had 1.5? Can we do the square root of 1.5? Yes, we get a positive number. Can we do 1.5 minus 1? We get 1/2. A positive number divided by a half, that's a positive number, so everything works well there. And our domain is from 1 to infinity.